In this video, we're going to talk about our last tool to help us understand and calculate probabilities. And this tool is called a Venn diagram. In a Venn diagram, we typically represent the entire sample space with a box. And remember that sample space is the list of all possible outcomes. And we represent the specific events that we're interested in with circles. If the events have outcomes that are in common, those circles will overlap in the picture. We saw an example of that in a previous video. If the events don't have any outcomes in common, in other words, if our events are mutually exclusive, that's not how you spell exclusive, try again. The circles should not touch. They should be nice and separate. So we're going to go ahead and fill out a Venn diagram and then answer some questions about it. So it says, suppose an experiment has outcomes 1 through 12, where each outcome has an equal chance of occurring. Let event A equal the numbers 1 through 6, and let event B equal the numbers 6 through 9. Construct a Venn diagram for this experiment. So first thing I'm going to do is draw a box. And that box is going to represent all of the numbers between 1 and 12. The next thing I need to do is draw a circle to represent events A and B. And in order to know whether they overlap or don't touch, I need to look at whether they have any outcomes in common. So I search this list 1 through 6, this list 6 through 9. I see that I have one outcome in common. 6 belongs to both of those events. So when I draw my circles, I need to make sure that those circles have overlap. There we go. All right, so next thing I'm going to do is I'm going to start putting numbers in spaces in the picture. So this is event A, this is event B, and I'm going to write the numbers in blue. So I know that the event that I circled in blue at the beginning, that's the overlap, goes in the middle between them. All of the other numbers in A go in the A circle, so 1, 2, 3, 4, 5. All of the other B numbers go in the B circle, so 7, 8, and 9. And then any numbers that are not in either list should be outside of those circles, but inside of the box. And I've got the numbers 1 through 9. I am missing 10, 11. I should be consistent with my colors. 10, 11, and 12. Those are possible outcomes, but they're not part of either of the events. So they go outside of the circles. The next thing I'm going to do in a different color is record the probability of being in each section in this table. And I'm going to answer some of these questions first. But let's take a look. So if I'm looking at the whole sample space, there are 12 numbers, so 12 possible outcomes. I know that outside there are 3 outcomes. In this bubble by itself, there are 5. In this section, there are 1. In this section, there are 3. I also know that all of B has 4 total in the B circle, and that all of A has 6 numbers in it. 1, 2, 3, 4, 5, 6, because that is in circle A, it's just also in circle B. That's going to help us answer these questions below. So the first says, find P, A, and B. And looking at my Venn diagram, and I'm going to do this in color here, A and B are the outcomes that are both. That's this region of my Venn diagram, and I can see that there is one number out of 12 possible outcomes. So the probability that I select a number that is both an A and B is 1 out of 12. For A or B, we'll go back to my highlighter. I'm going to do this guy in blue. A or B is everything that's in A and everything that's in B. And you'll notice that A and B have overlap, so when I do this, I have to remember to subtract off the double count when I use my addition rule for the OR. So A has a total of 6 outcomes in it out of 12 total. B has a total of 4 outcomes out of 12. And there is 1 outcome that got counted twice, the 6 that's in the overlap. So 6 plus 4 is 10. 10 minus 1 is 9. So this is 9 out of 12, which are both divisible by 3. So that's going to be 3/4, or 75% of the numbers. And that makes sense because I can see that 3 out of 12 are outside of that colored region. 3 out of 12 is 1/4. So it should be 3/4 that are inside the colored section. All right, our last one says not A and not B. Not A and not B. I'm going to do that one in pink. So not A is everything outside of A. Not B is everything outside of B. And both of those together is all of this space outside of the circles. And I can see that outside of the circles, I only have 3 numbers. So the probability that I randomly select a number that's not in A and not in B is 3 out of 12, which is 1/4. So that's how, or some of how, we use Venn diagrams to help us solve probability problems. They're great at organizing situations where we have a complex series of events. I like them because I'm a very visual learner. If you have questions on how to build your Venn diagrams or how to read them, feel free to send me an email or drop by our Thursday office hours. Otherwise, I'll see you in our next video.